So today we are honored to have the perfect professional to help us better understand why it's important for early detection of Alzheimer's disease and related dementias. No matter where you are on this journey with your loved one living with dementia, a proper diagnosis can help put you on the right course for treatment. Dr. Rosie Curiel Cid is the Associate Professor of Psychiatry and Behavioral Sciences at the University of Miami Miller School of Medicine. She serves as the Chief of Cross-Cultural Neuropsychology and Cognitive Neurosciences at the Center for Cognitive Neuroscience and Aging. She is also the leader of the Outreach, Recruitment and Engagement Core of the One Florida Alzheimer's Disease Research Center. Dr. Curiel Cid is the neuropsychologist with expertise in assessment of neurodegenerative conditions among older adults at risk for diseases of the aging brain, which includes Alzheimer's and dementia. She is the principal investigator of a study funded by the National Institute on Aging entitled Precision-Based Computerized Assessment for the Detection of Mild Cognitive Impairment in Older Adults. She has a strong desire to use new technologically enhanced innovations to help detect preclinical degenerative diseases. She's working hard to ensure that these advancements in methodologies are available to understudied and underserved communities. This goal is to ensure there's inclusion of diverse older adults in research as well as outreach programs. As we know, dementia has no boundaries. She's been nominated and won many awards. She has a strong passion for teaching. She works with undergraduate students as well as postdoctoral fellows to present subject matters about neuroanatomy and neuropsychiatry in user-friendly ways for them to learn. Those doctors can then present this difficult information in a manner that's easier for us folks to understand. Her passion goes beyond educating professional colleagues. That's why she's generously taken time away from her busy day to be here with us. In addition to her professional expertise, she's the mother of 2 little boys who love being at the beach. Cooking is one of her passions, as well as weightlifting and writing poetry. I don't know how she does it all, but we're fortunate that she's here with us today. So let's get ready to listen as she shares her knowledge in a way that can be easy for us to understand. Thank you, Doctor. The meeting is now yours.
Thank you so much, Sherry. Thank you for that beautiful introduction. I'm very honored to be here today with everybody this afternoon because I just love to talk about different things that affect us as we age and ways that we could take the bull by the horns and empower us to do better every day to maintain our health, to maintain our brain's health. And so I prepared a presentation for you that can give you a little more insight as to what we're doing and hopefully convey that, you know, it's important. It's important to detect diseases early. The first thing I'd like to reiterate is that I work for a wonderful institution, the U. So for those hurricane fans on the call, we're delighted to have you. If you're not a hurricane fan and you're a Gator fan, we have a place for you as well, because the One Florida Alzheimer's Disease Research Center is a big collaboration between the University of Miami, the University of Florida, Florida International University, Florida Atlantic University. Basically, what we did was that we came together as earth, throughout the entire state of Florida, scientists and doctors that were studying Alzheimer's disease in different institutions, and we're working together as one in order to improve what we're doing, to learn from each other, to share data, to share methodology, and we're doing this right in the state of Florida. So it is a consortium of Florida institutions helping to change the current understanding of Alzheimer's disease and related dementias from being incurable, inevitable, and largely untreatable to a new reality in which these diseases are curable, preventable, and treatable. And this is the One Florida Alzheimer's Disease Research Center. And the purpose is to really translate advances in research and improve diagnosis into the clinic so that doctors that are seeing individuals that might have memory concerns, not only specialists, but also what we call the frontliners, the primary care doctors that oftentimes receive concerns or complaints about loved ones or people themselves that might say, you know, I feel like my memory is changing, or I can't multitask the same way I used to, or I'm losing, I don't enjoy participating in conversations as much because I'm losing the course of the conversation. And individuals oftentimes have these memory concerns, and they go to their primary care doctor that they've been going to for 20 or 25 years, and they say, oh, come on, Sherry, you're doing great. I know there's nothing going on, right? And in reality, that doctor should be taking the complaints seriously, because as many of you know on this call, age is the primary risk factor for the development of Alzheimer's disease and other diseases of the aging brain. By the way, age is a primary risk factor for diseases to just about any organ. But one of the most precious, I say the most precious organ we have, it's arguable, we can have a debate about it, is our brain. Because from this central executor computer, we can do so much in our lives. And if we don't have our full faculties, as you know, we need help to do things in our lives. And that becomes troublesome for some people. So we translate those research advances into the clinics. We advance efforts to find a treatment or a way to prevent Alzheimer's disease and other types of dementia. We provide outreach and education to individuals, communities of all kinds that reach out to us to say, I have a group of individuals that might want to learn more, or we know about this, but we want to know about the newest drugs that came out, or about these blood tests we've been hearing about. And so sometimes it's very specific. And of course, we train the future generations. We're universities, and so we train the future generations of doctors and scientists that are going to take over for us, and to make sure that all of these things put together is the goal is to live in a world without Alzheimer's disease and related dementias. And we have our sponsors that support us, primarily the National Institute on Aging and the Florida Department of Health, which we're very grateful for. There's only we are one of only 37 Alzheimer's disease research centers in the entire country. Some of you may have heard of centers of excellence, right? This is a center of excellence in everything that has to do about Alzheimer's disease. Diagnosis, treatment, research, education, it's a hub so that we produce the best and most state-of-the-science work related to Alzheimer's disease, and other research groups in the country and across the world come to us to learn how to do it better. So this is the consortium of institutions across the state that I had previously mentioned. And we have two main themes. The central theme is the early detection of very subtle cognitive transitions that occur during pre-symptomatic stages of the disease. That is, when a person essentially has no symptoms or such minimal symptoms that they're not too concerned. but maybe they have a family history, or maybe they're very conscientious and want to get themselves checked out, right? Or they want to participate in research because they understand the value of contributing to science. So very early cognitive transitions. And if you think about this, there are other models in medicine that have really looked to early detection efforts and have been very successful. You may remember that in the 1980s, when someone was diagnosed with cancer, oftentimes that was a big problem, not only because there weren't enough treatments, but because it was too late. It hadn't been detected early enough. But the field revolutionized, and they went towards early detection in cancer care, which is they started recommending mammograms and prostate exams, right? And then these sort of screening measures allowed for very early detection, to the point that many cancers that are caught early enough are very treatable and essentially just become a chronic condition that people live with, but don't necessarily lead to severe illness or death in a lot of cases, particularly prostate cancer and breast cancer. We've made a significant improvement by turning to that early detection model. So in Alzheimer's disease, we believe that we could be the same, that if a person starts to experience minor cognitive breakdowns, the goal is that A, that doesn't happen at all, or B, that it could stay very minimal and not affect a person's life to the point that they lose their independence. And so the second central theme is cross-cultural application. We are in Florida and the country, I should say the country is about 39% now non-white. The individuals from many different places, groups of growing Hispanics and African Americans and Asians predominate. So there's a lot of individuals that are varied in their cultural practices, and our culture and the way is basically the way we live our lives, the food we eat, how we take care of ourselves, whether we prioritize going to the doctor or not, but also whether we have access to that kind of care. And that could lead to having good health outcomes as an older adult or poor health outcomes as an older adult. So that's important too, to make sure that the science we're creating is applicable not only here, but in a village in China, right? So we're trying to make our science as global as possible, because Alzheimer's disease is a global priority. It is not only a United States priority, it is happening across the world as the population ages. So we know that by the time a person has been diagnosed with dementia, there's been significant deterioration that occurs in a person's brain. Significant deterioration. I've heard some of my colleagues say, essentially, it's almost as if the brain is in organ failure by the time a dementia is diagnosed. Raise your hand if you want me to share what the difference is between Alzheimer's disease and dementia. Does anybody have that question? Okay, all right. I asked because, so many people ask me this question, and I want to make sure that I answer it because it's very common. Alzheimer's disease is just one type of dementia. Dementia means when a person, there is a state of dementia, it means that the person has had memory or thinking abilities affected to the point that they need help to take care of their day-to-day life. But dementia could be caused by many different things. A person can develop dementia because they have cerebrovascular disease and it causes a stroke, and that could lead to dementia. A person can have multiple vitamin deficiencies and malnutrition, and that could lead to dementia. By the way, that could be reversible, right? A person could have a neurodegenerative condition like Alzheimer's disease, and that could lead to dementia. So Alzheimer's disease is just one type of dementia, but it is the most common type of dementia, which is why we hear so much about it. And Alzheimer's disease is also a progressive disease, which means that it's very slow and it develops over many years. In fact, we find that people that are affected by Alzheimer's disease have the changes in their brain that are occurring at the cellular level up to 2 decades before they have any symptoms at all. And we're able to visualize those changes now on a scan called an amyloid PET scan, which I'll show you. So we can see a person's brain starting to accumulate the Alzheimer's disease pathology 2 decades before any symptoms manifest. That's really important. That's really remarkable, because that means that there is an opportunity to have close monitoring of the individual and get them the help that they need, and also have them engage in ways to care for their brain. What I said in the beginning, and I'll kind of repeat it again and again during this talk, there's a lot we could do for ourselves to prevent brain disease and to prevent that we manifest the symptoms of Alzheimer's disease, even starting, and importantly starting, in our midlife. So the earliest detection of Alzheimer's disease and related disorders, Lewy body disease, Parkinson's disease, these are all related neurodegenerative conditions that are slow and begin to affect the brain over time. And again, age is the primary risk factor. If we catch it early enough, we can enter during a window where the brain hasn't deteriorated, and we can apply some new medications or some new therapies in order to try to prevent further decline. I call it the speed bump, right? Is there any way we can lay down the speed bump so that a person's memory and thinking abilities don't continue to decline, right? So before we even say the word cure, I like to be very realistic with people, and I say, listen, everybody wants a cure. Sure, I drive down a busy traffic highway every single day to my hospital to do my work, because that's what we're shooting for. We're shooting for a cure. But before a cure, we need at least a medication that is modifying the course of the disease, that is putting down the speed bump so that the disease cannot advance. Everybody follow me so far? All right. So thank you so much. So we really want to catch individuals during a critical period, during a stage where there's only mild cognitive impairment, and try to slow things down. And that's why early detection is so important. So I'll tell you a little bit about what we're doing to achieve this. We at the University of Miami, and our center, specifically the Center for Cognitive Neuroscience and Aging, has developed what we call cognitive stress test. Raise your hand if you ever heard of, or if you've ever had a cardiac stress test. Raise your hand. Yeah. So sometimes, you get an EKG and it looks a little funky, or the cardiologist, they really want to check a little further, and they want to check for subtle cardiac dysfunction, because, that EKG may be too gross of a measure. So they want to check to see if your heart has very subtle dysfunction. So they put you on a treadmill, they inject you with thallium, and they get your heart racing, right? Sometimes they put a mask on, they'll limit your breathing, etc. It's really tough to do. That's called the cardiac stress test. Well, our tests are called cognitive stress tests, not because they cause a person to be in distress, right? But because they have been able to pick up on very subtle changes in memory that occur during pre-symptomatic stages of Alzheimer's disease. And these cognitive stress tests have also been associated with the disease that's brewing inside the head, the accumulation of beta amyloid protein, the accumulation of tau with neuroinflammation, etc. Since we can see the disease in the brain years before symptoms manifest, these stress tests have also been able to pick up on very subtle cognitive changes where other kind of widely used tests that they use in regular neurologist office or regular memory disorders offices don't. Okay, so it's an innovation on the way that we're measuring change. And that's been pretty well received. So we were featured on the front page of the National Institute on Aging's website. Cognitive stress test predicts high levels of beta amyloid. And we were pretty proud of that the NIH thought that our work was significant. Beta amyloid is a protein. It is essentially the protein that is associated with it. Once it accumulates, it's associated with those plaques that we see in the brain that accumulate over time. These plaques essentially cause the neurons of the brain to not talk to each other. The communication falters. And if one neuron can't talk to the other, then that neuron dies and it causes atrophy. And the atrophy is the plaque. Essentially, it's the hole. Sometimes you see these dramatic pictures of a brain with advanced Alzheimer's disease and it looks like it has holes. Well, those are plaques that are caused in the brain. So beta amyloid is the protein that can be measured in vivo using something called an amyloid PET scan. It could be measured in other more innovative ways now, which I'll talk to you in a minute. But just to give you an idea of some of our science, one of the major things we do is the development of new ways to test people's memory and thinking abilities. So it's really important that the field has these new ways to test memory and thinking. It's almost like, imagine we were still depending on x-rays in medicine, right? We didn't have MRIs and we didn't have CT scans and we didn't have ultrasounds. Well, that would be a big problem for us. But there have been innovations in the neuroimaging that have allowed us to be able to see the neuroimaging allows any kind of imaging. It's almost like it allows the doctor to augment their own vision to see within the person's head, right? To see what's going on. It's fascinating. Well, the clinical examinations can't be what they were 70 years ago. And a lot of these neuropsychological tests were developed as part of the Army Alpha Battery, right? Goes way back. No good if you want to detect very subtle changes that occur in people, particularly well-educated people, particularly very smart people. You have to be very subtle in the way that you measure it. And we have to have these tests help with detecting what's normal aging or what's very mild illness. The tests have to be able to do that. And they have to track over time so that we can see the same person's performance over time and that have meaning. The tests have to converge with these novel biomarkers, the imaging, the blood test has to converge in order to see if when that medication if that medication is working and that person's getting better, it has to be able to measure that. So this therapeutic window is very important, and our work helps to enable the effectiveness of identifying when a person is in a therapeutic window. Of course, in a lot of Alzheimer's disease clinical trials are really focused on prevention, and this sort of work will help individuals identify who is a perfect person to enter these clinical trials, using tools, of course, that are non-invasive and inexpensive. So if you go to a clinic and you have a concern about your memory, there's a long history that's taken. They're going to do a medical examination. They're going to measure your memory in traditional ways. But fortunately, these tests are now available clinically for use by clinicians and are being used in different memory disorder centers in the United States, and then been translated and validated in probably over 8 languages right now. So we're pretty happy about that. So our cross-cultural applications, this is an outdated map. I didn't update it for today's presentation. I have more stars. It just shows the different collaborations that we have across the world that are looking at our cognitive stress test. And it's been used in conditions other than Alzheimer's disease. It's been used in conditions such as Huntington's disease and multiple sclerosis and Parkinson's disease. And another group looks at it in terms of COVID-19 and the effects that COVID-19 had on the brains of older adults. We have 3 clinical core sites where we evaluate individuals at the University of Miami, at Mount Sinai Medical Center, and in Gainesville at the University of Florida. I heard people say the villages. Do most individuals in this group live in that area? No, or it's all over? So it's a true virtual platform where, yes. So great. So we're throughout the state. So this is an example of an MRI, or a magnetic resonance image. It's a very standard neuroimaging tool that's used right now. And it tells us a lot of information, but it's not diagnostic for Alzheimer's disease. It's just a tool that helps us inform. So for example, this is the top slide here is a young individual. And what we're looking at is, if you take kind of like a crown, if you take the brain and you slice it this way, you're looking at a coronal slice of the brain that captures this area, which is the medial temporal lobe, where there's a structure called the hippocampus. The hippocampus is responsible for forming and maintaining and accessing memories. Even though memories are kept all throughout our brain and body, the hippocampus is really important in terms of the maintenance of memories and the access of memories. If you see, this is a young individual, you see their hippocampus is pretty full. There's not a lot of atrophy. There's normal grooves, the sulci, the gyri, that's normal, but it gives us a reference. This is a person who is an older person, but there is no disease in their brain. This is the hippocampal formation here. And then you can see that there is not as much tissue as on the top, right? But it's pretty well formed. Here's an individual who has mild cognitive impairment. So this is their hippocampus. You'll see that there is more atrophy, more whole, more of the black part. Right? There's more atrophy here as the brain, those cells again, the pathology accumulates, those cells start talking to each other, and the brain becomes atrophied. And this is the person who has mild Alzheimer's disease. If you look here in this part of the hippocampus, you'll see that there's substantial more atrophy. So the brain is starting to deteriorate, and there's a lot more of the black, which is the whole, right? So there's a lot more atrophy. This is just an example when you get an MRI at the doctor's, what kind of information it gives the doctor. This medial temporal lobe is really important to Alzheimer's disease. It tends to aggregate, it tends to collect in the medial temporal lobe and then spread throughout the brain. So we try to take a close look there. But Alzheimer's disease, if you just generally look at the top one, or even here in the person who is an aged control, you'll see that there's kind of larger grooves or larger sulci and gyri, but here it's more general too. So it's not only here, you'll see that there's greater black spaces here. So it starts to really generalize. This is an example of an amyloid PET scan. I mentioned an amyloid PET scan, and there's breaking news. As of last week, the Center for Medicare and Medicare Services, CMS, they began to now cover an amyloid PET scan. So before, this type of scan was only used in research labs, Now it is available in clinics. Now it's going to be available in clinics because Medicare is going to pay for it. And the scan costs thousands of dollars. And I'm sure it'll take some doctors and hospitals some time to develop the infrastructure. If you go to a research hospital like the University of Florida, the University of Miami, where they do research, we already have the infrastructure to see clinical patients and follow a well-established protocol. But other community hospitals are going to take time to be able to integrate this. But Medicare now covers this scan, and it is a very important diagnostic tool. If you see on the top left, this is an example of a person who is an older adult who is completely cognitively normal. They have no amyloid in their brain. If you look down here in this part, you'll see a person who has mild cognitive impairment, but they have no amyloid. So their mild cognitive impairment might be due to something else. But look what happens if you look at the bottom right here. This is a person who has mild cognitive impairment, but it also has amyloid positivity in their brain. You see how the scan lights up very differently and is showing the presence of beta amyloid protein accumulation, particularly again in those medial temporal areas and in the cortex, and in the frontal aspects of their brain as well as the parietal aspects of their brain. And when you have Alzheimer's disease, this is on the top right, this is an example of someone who has Alzheimer's disease, who's amyloid positive in the dementia stages. And here you see a lot more red and orange, and that is the uptake or the presence of that beta amyloid protein is clearly visible. Well, the scan, as you can see, is very helpful for doctors to diagnose Alzheimer's disease. So there's going to be much less ambiguity as to what kind of dementia a person has, whether the complaints are due to normal aging or whether indeed there is a disease process. In fact, when my patients come to see me now, I say, how much do you want to know? I ask them, because we can tell you a lot about your risk factors. Now, I will say that I have patients who have positive amyloid scans, no cognitive complaints, have an ApoE4 gene that renders them at higher risk for the development of Alzheimer's disease. And I've been following them for 8 years, and they're going on their 2-mile walks every day and traveling, and they're living their life, and they're very healthy, and there's no symptoms of Alzheimer's disease. So every person is their own individual, and all of these are only tools to help us to reach to the point that we can say, you're at high risk, you're at low risk, you have no risk, right? But it's all about a risk calculation when we make the diagnosis. This is an example of a tau image scan. Tau is another very important protein that in the Alzheimer's disease brain misfolds and tangles up that neuron and again causes it to die. Tau is, this is an example of a young adult. This is a person who is older, who is negative. This is a person who is positive. And then this is a person with Alzheimer's disease. And so you can see that there's differences in the accumulation of the tau protein. We can image that now as well. This is not moved as quickly. This is newer technology, so it is not approved by Medicare yet. We're still exploring it and studying it, but it is used in our research at the University of Miami. And there's other markers as well that don't involve imaging. For example, genetics. So whoever has heard of a gene called the ApoE4, raise your hand if you've heard of apolyprotein E4. So there is a gene that was discovered that renders risk for the development of Alzheimer's disease. If you get a 4 allele from mom and a 4 allele from dad on this ApoE4 gene, you are at 8 to 14 times more likely than the person who doesn't have that gene or those alleles to develop Alzheimer's disease. That's not necessarily true for African Americans or Hispanics, but it is mostly true for individuals that are of white European descent. Okay, so this ApoE4 gene, it isn't all. I get the question all the time: is Alzheimer's disease inherited? Well, the answer is it could be. It could run in families, but it's not. You're not doomed. If your parent had it, if your grandparent had it, it only means that you're at 8 times higher risk, 14 times higher risk, but it doesn't mean you're at 100% risk of getting it. Now, there is one type of gene called presenilin 1. This accounts for only about 1.5% to 2% of cases worldwide of Alzheimer's disease, where the person will develop Alzheimer's disease if they have this presenilin 1 gene. And you may have heard that there are villages, for example, in Colombia, where there's an entire kindred of families that develop Alzheimer's disease. And it is one of the most heartbreaking societies, to care for, because the little ones, when they're adolescents, they start to have to care for their parents who develop Alzheimer's disease in their 40s, and then they develop it early. It is early onset. So this is a group that needs a lot of our support and help, and it's a very important kindred to study. So also, guess what? Quest and other companies have developed these assays, or basically these blood tests, to be able to measure the presence of beta amyloid protein and phosphorylated tau protein in the blood. And I'll never forget, I went to a conference, and this is probably 2011 or 2012, and I went by one of the booths, and there were these Korean scientists, and they said, we can detect amyloid beta protein in the blood, and we've developed this method. And I walked away thinking, no way, there's no way they can do that. Well, guess what? That science did develop, and it's remarkable. Why? Because now these expensive images, PET scans, cost thousands of dollars, and they're not available in every community. Now we have a way to be able to have this other marker of risk, the detection of the proteins in the plasma. So by giving a blood sample, your doctors, which is now also covered by Medicare, can do a blood test in Quest that can tell the doctor whether or not these proteins are in your blood. So is it diagnostic? No, it's only one tool used in the entire picture for diagnosis, but it helps to get us closer to early detection. So here's what those plaques look like. So this is an example of the neuropathology of Alzheimer's disease. This is a plaque that's caused by the amyloid, and this is a neurofibrillary tangle that's caused by the tau. So when they look, this is a slide from a sample of brain tissue where you can see both the amyloid plaque and the tau tangle. And this is how a neuropathologist will confirm on autopsy that indeed there is Alzheimer's disease. When I went to school, there was no way to confirm Alzheimer's disease unless a person had an autopsy. It's still the best way, but now we don't need that. We can confirm, in vivo that there is amyloid pathology in the brain before a person passes away. So I just want to mention my collaborators across the state of Florida, the country, and the world. And we're so grateful for them and for you. I always say to people, even if the National Institute on Aging gave us $1 billion, we can't advance the science of Alzheimer's disease without people participating in research. And so if you haven't already, consider doing so wherever your local clinical research center may be, or clinical trial center, and